Welcome back. This is Mr. Hassan's Maths channel, and there is a question that I'm going to answer now, which is from one of the papers that I made as a practice paper for P3, which I made some time ago before the first papers were released. And this question is a question that is related to a new topic in P3, which is to do with integration. Okay, so the last part of this question is to do with integration, P3 integration, which before in the old C3 syllabus, it wasn't there. So I found this question from a paper from some other syllabus from Cambridge. I think it's from Additional Maths, question number 7 from the May-June 2012, I think the Additional Maths paper. So I took that paper from there and I put it in my practice paper. And one of the students who was doing those papers, he asked me to answer this question. So I'm answering this question on his behalf. Now, this question here is about a trig function. We got the graph of y equals 1 minus 2 cosine 3x, which crosses the x-axis at the point A and has a maximum at the point B. We're first of all asked to find the coordinates of the point A. So we need to find the coordinates of the point A. That's the first thing we have to do. Now we can see that at A, it's crossing the x-axis. So we can say at A, say we're on the x-axis, and we know on the x-axis, y is equal to 0. Okay, the x-axis is the line y equals 0. So if I replace the y with 0 in the equation, then what will be left will be, it will tell us if I solve the equation that remains with for x, it will give me the place where the curve crosses the x-axis. So if I put 1 minus 2 times the cosine of 3x and I make that equal to 0, that will give me the solution of my equation. So if I rearrange this, I'm going to get cosine of 3x is equal to a half. So I can find my solutions. So I say inverse cosine of a half. Now the inverse cosine of a half. Now my answer here can be in degrees, can be in radians. Right, for part 1. I know eventually I'm going to find the area under the curve. And when you're dealing with, and which will of course involve integration. Now when you're dealing with integration or differentiation and trig functions, you must always work in radians. So although part 1 and part 2 of this question does not require me to put my answer in radians, I'm going to put them in radians anyway because I know I'm going to need my answer in radians for the subsequent questions. But if you put your answer in degrees for part 1, there's absolutely no problem. Okay, unless the question states it, you could put it in degrees. There's no problem with that. So inverse cosine of a half gives me 60 degrees or pi over 3 radians. Okay, pi over 3 radians. And that is the answer. Now, there are other places where it hits the x-axis. One's going to be back here, one's going to be over here. And I can find them by saying, okay, the other part where it hits the x-axis is minus pi over 3. And the other part where it hits the x-axis is, 2 pi minus pi over 3. But we only want the first place where it crosses the x-axis. I don't want the other place. I want this place. So I don't find the other solutions to this. I only find this first place where it crosses the x-axis. That's what I'm looking for. That's the coordinates of A. So now that means the x coordinate for this point, I have to divide by 3 to find the actual x coordinate. That's going to be pi over 9. That means the coordinates of A are the x coordinate pi over 9 and 0, the y coordinate 0. I could write this as 20 degrees and 0 if I wanted to. I could write that if I wanted to, 20 degrees and 0. That's fine as well, because that's pi over 9 is 180 over 9, which is 20, yeah. But I would prefer to leave my answer in this form, because I know I'm going to use, I'm going to have to use radians when I'm dealing with the third part of the question. All right, so there's question number 1 answered. Now for question part 2. Question part 2 says, find the coordinates of B. So now I've got a little copy of that diagram here. So the coordinates of B. Now B is the place where the curve has a turning point. Okay, it's the first place where it has a turning point after 0. You can see there's one at 0 as well. So when we solve that, we have to keep that in our mind, right? Now, so there's a couple of ways we could answer this question. Most probably the simplest way is to take the equation, which is y equals 1 minus 2 times the cosine of 3x, and we know at the turning point the gradient is 0. So we can say at B, okay, we can say dy dx is equal to 0 because it's a turning point. All right, so we can say dy dx is equal to, the 1 becomes 0. So we have, when we differentiate cosine of something, it becomes negative sine of the same thing. Okay, so we have minus 2 times, I'll just write this in a bracket, minus sine of 3x, but then I have to multiply by the differential of what's inside the function, so I have to multiply that by 3. So I end up with negative 6 or positive 6 sine of 3x. Because you have minus times minus, 2 times 3, so you end up with 6 sine 3x, and that's what dy dx is. So now we know that at the place where the gradient is equal to 0, that's where B is, so we can equate the gradient to 0. So 6 times the sine of 3x is equal to 0, which means the sine of 3x is equal to 0. Oops. So now we can say that, which means that 3x is equal to, now it's either equal to 0, right, that's this point here, or it's equal to pi minus 0. The next time it hits 0 is pi. That's for 3x. But for x, we've got to divide by 3, so you have 0 and we have pi over 3. That is the one we're looking for, pi over 3. That's the point we're looking for. So we know that this is pi over 3, the x value. We need to find the y value. Okay, then another point where the gradient is 0, that would be that minimum point. Looking for the maximum point, which you can see is the first place there, and B. So now we need to find the y coordinate. So we know that y is equal to 1 minus 2 times the cosine of 3x. So we can say that y is equal to 1 minus 2 times the cosine of, you have 3 times 3 pi over 3, which is pi. If I replace the pi over 3 in the x, I have 3 times pi over 3, which is pi. So we say y is equal to 1 minus 2 times the cosine of pi is negative 1. Okay, because the cosine curve goes like this. Pi. Yep. So that's going to be y equals 3. Of course, you can use your calculator for that. I just know after all these years what cosine of pi is. Now, that means the coordinates of B, the x coordinate is pi over 3, and the y coordinate is 3. Okay, so that's pi over 3, and that's 3 over there. Okay, so that's what we can deduce or we can find from this question. So that's probably the easiest way of finding B. There's also another way of finding B by using transformations. Because we can think about the cosine curve. We can think about the cosine curve. If you draw the cosine curve between 0 and 360, it's going to look something like this. Okay, that's y equals cosine x. Right, let's go through all the transformations here. So cosine of 3x will mean it gets squashed. So instead of this being pi, this becomes pi over 3. Okay, instead of this being 2 pi, this becomes 2 pi over 3. Instead of this being pi over 2, this becomes pi over 6. Instead of this being 2 pi over 3, sorry, 3 pi over 2, sorry, normally be 3 pi over 2 becomes 3 pi over 6, which is now pi over 2. It's 270 divided by 3, 90, yeah. So all of these values that were normally like this would be 90 degrees, it's now 90 divided by 3, which is 30 degrees. This would normally be 180 degrees, it's now 180 divided by 3, which is 60 degrees. pi over 3. This would normally be 270 degrees, now it's 270 divided by 3, which is 90 degrees. And this would normally be 360 degrees, but now it's 360 divided by 3, which is 120 degrees. So in terms of pi, it's these values. So that's when you put cosine 3x now. So that's y equals cosine of 3x. Then what happens is, it is multiplied by 2. It's multiplied by 2, or you can say multiplied by minus 2. Now when it's, at the moment this is 1 and this is 1, minus 1. When you multiply by 2, it gets stretched. So this becomes 2 and this becomes 2 and this becomes minus 2. Okay, it's multiplied by 2 because you have 2 cosine 3x. And you multiply by minus a negative in front of the whole function, it basically reflects in the y-axis, and so in the x-axis. So it's going to look the mirror image. So the graph is going to look something like this. Let me just draw it in a slightly different color. Okay, so the graph is going to look something like that. The actual graph is going to look something like this. Okay, and then the last thing that happens is you add 1 to the whole function. So the whole thing rises by 1 unit. So this becomes minus 1, and this becomes 3. So you can see that the coordinates of the point B, which is up here, is now pi over 3 and 3. Okay, pi over 3 and 3, which is exactly what we got by considering the turning point. So this is a bit more thinking involved, okay? Doesn't involve any differentiation, it just involves transformation of the graphs, but it's nice to just fit it in together with what we've learned from the past, maybe to make you understand that. I mean, personally, in an exam, I would just stick to this method here because it's a bit simpler and doesn't require so much thinking. But this is a nice way for you to fit in transformations and differentiation and how they work together. So there's the answer to part 2. Okay, and so we found the coordinates of A, pi over 9, 0, and the coordinates of B, pi over 3 and 3. So now part 3 of the question is asking us to show all the working and find the area of the shaded region bounded by the curve, the x-axis, and the perpendicular from B to the x-axis. So this region here, which is shaded. Now we worked out that this point A has coordinates pi over 9, and the coordinates of the point B, so this point on the x-axis point here, is pi over 3. Okay, and we need to find the area under this curve between those points, between the curve and this, and the x-axis. So we need to integrate between the limits of pi over 9 and pi over 3, 1 minus 2 times the cosine of 3x with respect to x. Okay, so that's what we have to do. Now, in order to do that, what we can do is simply integrate our function. So this is why I expressed my answers in terms of radians, because when we integrate or differentiate, we must deal with radian measure with trig functions, All right, so that's why I gave my answers in terms of pi, where I could have written these answers in terms of degrees if I wanted to for part 1 and 2. All right, now to integrate this, we'll start integrating it now. Well, the integral of 1 with respect to x is x. To integrate cosine of something becomes the sine of the same thing. So this will become minus 2 times the sine of 3x. But then I have to divide by the differential of any function that's inside the function. So I have to divide by the differential of 3x, which is 3. I'll divide that by 3. And we're done with the integration. Now we have to use the limits of pi over 3 and pi over 9. Okay, so we're almost there now. So now we're going to substitute these values inside instead of x. So the x is pi over 3 minus 2 times the sine of, this is 3 times pi over 3, which is pi. over 3 minus, and then we're going to have pi over 9 minus 2 times the sine of 3 times pi over 9, which is pi over 3. That's divided by 3. Okay, so here we have pi over 3. Now the sine of pi is 0, so that becomes 0 minus, and then I'm going to have, let's keep it in the bracket for now. You have pi over 9, and this gives you minus, now you have 2 over 3 times, now the sine of 60 degrees, sine of pi over 3 is root 3 over 2. Okay, so this, the 2's will cancel, leaving with root 3 over 3. So we have pi over 3 minus pi over 9 plus root 3 over 3. Okay, so this is like 3 pi over 9 minus pi over 9. That's 2 pi over 9 plus root 3 over 3. Okay, that's 3 pi over 9. That's right, minus pi over 9. That's good. Now, it says find the area of the shaded region. Okay, it didn't say find the exact area. Okay, so you could write your answer in decimal form. Okay, you could find the answer in decimal form, which is fine if you did that, but leaving it in third form is probably, better. Okay, easier for you and better. So here we have the answer to this question in third form, the exact area. Now, if the question said find the exact area, then you would have to leave it in third form. Okay, you'd have to leave it in this form in terms of pi and in terms of roots. You would have to leave it like that. But in this question here, it doesn't state it, so you could put it in decimal form as well. Okay, so there's the answer to part 3, and that completes this question, question number 7 from the CIE paper, and I can't remember, I think question number 9 from the practice paper of June 2015. So I hope that was clear. Thank you for watching. Other questions that you might want to, other questions from this practice paper, okay, if I'm asked to answer some more from this paper, will be in the playlist that will show over here. Other questions from P3 integration will be in the playlist over here. You can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.